Hello guys, in this video we are going to talk about set. Numbers such as root 2, root 3 are called set since they do not have exact values and are irrational numbers. We can only say that root 2 is approximately equal to 1.1414. If a calculation requires an exact answer, irrational numbers must be left in the set form. However, root 4 and root 9 are not set because they have exact values. For instance, root 4 is 2 and root 9 is 3 respectively. Other examples of sets include root 5, root 7, root 11, and many more. In general, the square root of all prime numbers are sets. Now, sets can be reduced to their basic forms. If root s is such that it cannot be reduced further, then it is said to be in the basic form. That is, or in essence, s does not contain a factor which is a perfect square. For example, root 2, root 3, root 5, root 7, root 11 are in their basic forms because they do not contain a factor which is a perfect square. Sets that are in their basic forms cannot be simplified further. However, root 24 has a factor which is a perfect square. So we can say that root 24 is equal to root of 4 times 6 because 6 times 4 is 24. So root 24 is the same as root 4 times 6. 4 is a factor and is a perfect square. It can also be expressed as root 4 times root 6. Root 4 is 2 times root 6, and this is equal to 2 root 6. Then we can say the set is now in its simplest form. What about root 75? Please feel free to pause the video and then try and solve. Root 75 is not in its simplest form because 75 has a factor which is a perfect square, and that factor is 25. So root 75 can be expressed as 25 times 3, and this is further equal to root of 25 times root of 3. Root of 25 is 5, root of 3 is still root 3, so times root 3 is equal to 5 root 3. Then we can say that this set is in its simplest form. Now let's talk about the addition and subtraction of sets. So addition and subtraction of sets. We can only add or subtract sets that are alike or of the same form. One thing you should note is that you have to reduce the sets to their basic form if they are not in their basic form before you can add. Let's look at the properties of adding and subtraction of sets. M of root k plus n of root k is equal to m plus n root of k. Notice that they are like. In the root we have a value called k, and in this root you also have a value called k. Therefore, these two terms are alike, and then we add the coefficient of them. So it is equal to m of root k plus n of root k is equal to m plus n all times root k. Let's say this is m of root k plus n of root p. This is not equal to m plus n root of k plus p. This is not equal to, it is wrong to do this because k and p are not alike. So in addition and subtraction of sets, we only add or subtract sets that are alike. And note that when the sets are not in the basic form, you have to change it to the basic form before you add or subtract. So let's say m of root k minus n of root k. Because the sets are alike, we subtract the coefficient. So m minus n all root k. Example 1. We are to simplify 5 root 2 plus 3 root 2. Are these two terms alike? Did you get it right? Yes, they are alike. Root 2 and root 2 is alike. So we add the coefficient. This is equal to 5 plus 3 root 2, which is equal to 8 root 2. Hope you've got it right. 2. What about 4 root 3 plus root 3? Are they alike? Yes, they are alike. Root 3 and root 3 is alike. So this is equal to 4 plus 1 root 3. And this is equal to 5 root 3. Note, the coefficient of root 3 is 1. But because it is 1, we don't really write it. So take note of that. So let's talk about the properties of sets. Properties of set. Now, property 1. Root of a times root of a is equal to root of a squared, which is equal to a. Hope you understand. Root of a times root of a is root of a squared, and this square cancel the square, and it is equal to a. 2. Root of a squared is equal to a because the square will cancel the square. 3. Root of a times root of a times root of b is equal to root of ab. So take notice of these properties of set. So let's try and solve questions on that. Root 2 times root 2. This is equal to root 2 all squared, and the square will cancel the square, and it is left with 2. In other words, you can solve it like root of 2 times root of 2 is equal to root of 2 times 2, which is equal to root of 4, which is root of 4 is 2. So the answers are still the same. What about 3 squared? Root of 3 squared. This is equal to 3 because the square is going to cancel the square.